Okay, this video is to help you get started on problem 7-17. So this is straight from the book. Since the log function is the inverse of an exponential function, the properties of exponents also apply to logarithms. The problem below will help you discover how exponent properties apply to logarithms. Complete the 2 exponent rules below. So this is why we reviewed our exponent rules. So x to the m times x to the n. Remember, when the bases match, you add them together. And x to the m over x to the n, remember when the bases match and you're dividing, you subtract them. So obviously that's going to have something to do with this because the book wouldn't remind us of that if it didn't matter. And logarithms are inverses of exponents, so we're going to keep that in mind. So to help you write the equivalent log properties, you're going to use a calculator to solve for x in each problem below. Note that x is a whole number in parts 1 through 5. Look for patterns that'll make your job easier to allow you to generalize in part 6. So we have log 5 plus log 6. So you have choices, right? Clearly it's log of a single number. And we're trying to guess what that single number is. There's only so many things you can do with a 5 and a 6, right? You could add them. You could subtract them. You could multiply them. And you could divide them. So what you would do is you would go grab a calculator, one of my calculators, make sure they all get put back in the correct spot afterwards, neatly, and you would type in log 5 plus, if the calculator starts a parentheses, make sure you close the parentheses, then you would type in plus, like I just said, log 6, and get a decimal answer. I'm going to do one with you to help. So log 5, close the parentheses, plus log 6. My decimal comes out to be 1.477 is close enough. You can see it on your screen. You don't need to press delete, just leave it there. Now try log of 11. Do you get the same decimal? Try log of -1. What happens? Try log of 30 and try log of 5/6. Pause the video and try it. You should realize or find out that log of 30 is the answer. So I'm going to erase some of my work here because I only have one page. I know that log of 5, this is what you should write on your paper, plus log of 6 ends up equaling log of 30. So when I was adding logs together, I ended up multiplying the numbers together. Well, look at this. When you add exponents, it's because you're multiplying matching bases. Interesting. See if you can finish the rest of these. You can use the calculator like I just said. And then down on C, so I should see all of these filled in on your paper. On C, you're trying subtraction. So I wonder how the exponent rule applies to subtraction. Again, 5 and 20, you only have so many options. You could add them. You could subtract them. You could multiply them, but we already found out the answer to multiply. Or you could divide them. One of these, the decimal you get, should match the decimal you get if you type this in. Again, your calculator will start a parentheses. You have to close that parentheses. It needs to look just like this before you hit equal and see if you can find the pattern. So that's problem 17. Then you also need to do in your packet, your note packet, there is a resource page that looks like this, the log puzzle. Once you figure out what happens, what the pattern is over here, you're going to fill out the log puzzle with all the different possible ways. So for example, we've only done one, but we kind of figure out that adding means multiply for logs. So if the answer is log base 3 of 60, that could be log base 3 of 6 plus, well, if I need to multiply to get 60, this must be log base 3 of 10. Same thing here. If I need to multiply to get 60, this must be of 20, etc. So use this video to help you accomplish the bookwork. Then watch the notes in Edpuzzle to get full credit, and then work on the rest of your assignment.